Thanks, folks. Great to be here. Now, I'm going to start with a picture of you, primarily because my boss asked for this. He wants to know I turned up. It doesn't say much about my reliability. What can I say? 15 minutes, and I'd like to talk to you about FIDO device onboard. And the big question I want to kind of answer for you is, frankly, what is it and why should you care? You have a million things to worry about as software professionals. Why should you add 1,000,001, right? Why one more? So let's see what we can do here. So first thing, got to point in the right direction. Who is FIDO? Well, we're an open industry association, and we're trying to frankly kill passwords. That's probably not the right words to use, but that's what we're trying to do. We're trying to get rid of passwords. Why? Because they're a nightmare. They're a nightmare for users. They're a nightmare for security. And we have about 350 members, and there's a few logos you probably recognize there. And one of the standards that you may know is passkeys, because I'm sure all of you, whether you've got email accounts or shopping accounts, have suddenly noticed it says, would you like to transfer to a passkey? And from then on, you can just touch your fingerprint. So that's what we do. But we have a standard that's really developed for devices, not humans. So normally with passkeys, it's about authenticating me. Is this Richard trying to open his email account? That's what a passkey does. What about a device? Got the same problem, basically. Whether you're taking a small IoT device, whether you have edge compute, whether you have a data center, there will be a point in life when somebody, a technician, walks into a building, plugs in the power, plugs in the network or Wi-Fi, and then there's this onboarding. There's this connection between the device and the management platform. And maybe it's a cloud, maybe it's a server down the hallway, but there's always that connection that has to take place. And what we want is something that's fast, and we want it to be secure, right? And we don't want passwords. Having some dude know your password in an energy situation or in a middle of a manufacturing plant is not good security. And it's also expensive having humans do that. It's inefficient. So we created a standard, our members, called FIDO Device Onboard. So let's kind of walk through. Imagine this hypothetical device thing is going to be manufactured and installed in some facility. So first things first, we put a bunch of credentials into the device at manufacturing. We do that with something called the manufacturing tool, but you can go do it what works best for you, and I'll come to that. The other thing we do is we put a software client in there that speaks FDO. And then the third thing we do, and this is the funky thing, is we generate this cryptographic document, if you like, this ownership voucher. And for those of you that remember Willy Wonka, it's kind of the golden voucher that says, if I have this, I am the legit owner of this device, and I can prove it. So what happens? The device merrily gets shipped somewhere. I did not do this animation. I wish I did. It wasn't me. And the ownership voucher gets loaded into the target cloud. And as I said, depends where that cloud is for you. Next thing that happens is the cloud registers that ownership voucher with something called the rendezvous server, which looks and smells a lot like a DNS. It's a redirect. So somebody takes the device, pulls it out of the box, powers it up, connects it to the network, and the first thing it does is kind of an ET call home. It says, I know how to call the rendezvous server. So it calls the rendezvous server, and it says, hi, this is me, who's my boss? And it gets redirected to the cloud. And at that point, the two of them can set up an encrypted tunnel, do their mutual authentication, cryptographic mutual authentication, set up a tunnel, and after that, you can start sending data back and forth. Now, you may have quickly noticed this ownership voucher and said, hey, Richard, what about that thing? What happens if I have people in the supply chain? Well, the answer is no problem, because that ownership voucher is cryptographically signed to each person in the supply chain. So it kind of goes from one to the other to the other. So let's kind of crack on. What happens after that? Well, data flows, and we're off to we're off to the races. And FDO has done its job. I'm going to come back to that That ownership voucher is what allows you to do late binding. It means you only have to build one device SKU for every customer. Every customer gets the same box. And it's the ownership voucher that tells them whether Bill gets it, or Grant gets it, or anyone else gets it. Okay, so who's using it? Obvious question. Are you going to be the first people? Well, few people in this room are using it. Microsoft, Dell, ASRock are doing it. ExxonMobil, by the way, I think you all know them, big company in energy. They're specifying RFQs now for their next generation automation systems, and it's mandated that you have automated secure onboarding. If you don't, you can't fulfill the RFQ. Red Hat, I think, are in the room. They've put it into an early release of RHEL, and we're working with the Wireless Broadband Alliance Open Roaming as well. So again, I'll talk to you, but I'd like to show you an organization who I think you know and let them explain why they like FDO.
Gerardo Diaz-Cuellar, I'm a partner software engineer, an architect at Microsoft. We have right now in our current landscape a very complicated device supply chain. And customers, keep hearing feedback that the main pain points for customers is that this is too complicated. They want a simplified management and provision device experience. In a few seconds, I'm going to show you a demo. This Azure Edge infrastructure is designed to address these problems that we've been talking about.
In this demo, I'm going to start from scratch and use just the things on the table here to create an infrastructure that can run all my workloads, VMs and containers alike. The first step is just to plug things in. So that means power and Ethernet. Next, we've got to install the software. Check this out. This USB contains a little restricted OS whose only job is to securely connect to the cloud. All I have to do here on site is plug it in, power on, and then wait until it powers back off again. Now, when these machines boot, they'll automatically connect to the cloud, which means from this point forward, I can do everything else remotely, like from my laptop. The trick is that on that same USB, there's now a little cryptographic voucher for each of these machines. That's what these two folders are, named after the serial numbers. I'll need these to claim the machines in the cloud. This is what prevents someone else from claiming them. Back in Azure Arc, let's go to this new area called provisioning. From here, I can install and configure the software that I want, including the operating system, onto these machines completely from the cloud. It's really cool. When it's all done, back in Azure Arc under Machines, voila, there they are, ready to go. I just set up these machines end-to-end without ever plugging in a keyboard and monitor. More importantly, if these machines had been destined for some faraway place, I could just ship them and the recipient would just plug them in. They wouldn't need any credentials or tech expertise. In fact, you can imagine that someday they might come from the OEM like this, and I just get the voucher that I need with the purchase order.
While not discussed in the video, all this was possible because Microsoft is embracing FIDO device onboard standards. With zero-touch provisioning onboarding, devices can automatically connect to Azure services upon activation. And because we are embracing these standards, we can ensure that our applications and the processes to set up the infrastructure has superior security, what our customers demand and need, including the supply chain attacks that we have all been familiar with in the industry. This is where we want our customers to go and the level of protection that we want our customers to have.
Hopefully that gave you a little taste of what Microsoft is doing with FDO. Now, one thing I did want to talk about, there's a lot of legislation out there coming out. Earlier I heard people talk about CRA, you've got NIST specifications on supply chain traceability, and FDO can kind of help there. And you're probably saying, well, why, how? Remember that ownership voucher? Well, it's cryptographically signed as it goes through the flow. So you kind of know who had it last, because you've got private, public keys all the way through. So we've got partners, we've got members building solutions to address this kind of legislation using FDO. So plant that seed in your mind. Moving on, where are we going next? You may say, well, is there any more innovation? Well, we're working on something called FIDO Bare Metal Onboard. So let me kind of explain what we want to do. At the moment with FDO, before you onboard, the assumption is you have the operating system and your applications already installed. And it can be done at manufacturer or at some staging point, but someone's done the work, and then you plug it in and onboard. The trouble is, of course, that takes time, money, effort. What happens if things go wrong? You have to send a technician out. Wouldn't it be nice if we could all do that at the location when the guy, whoever does the plug-in, could do it then? And the answer is you could. So with bare metal onboard, what we want to be able to do is have the base OS delivered to the device after it's been installed. So when you plug it in and power it up, it says, here, boom, this is your OS load. And that's done by embedding FIDO right down in the foundations of pre-boot. So start thinking about being in that boot up phase. But you may say, well, is that it? Well, not really, because you can go one more trick, which is once you've installed the base OS, you can actually run it again and say, well, now I'm going to run FIDO after BMO. I can actually then download credentials, certificates, applications, containers, VMs. All of that can be sent down afterwards. No human intervention, highly secure. And if everything goes really pear-shaped, you can hit the big green button and send it back to a known good state. Now, in terms of manufacturing flow, it changes the game, because today, this is kind of how it is, right? You build the box, stick the software, ship it, install it, and then update it as needed. In this model, you build the box, you put FIDO and BMO on it, you ship it, and then everything else you can do remotely. If you need to change the software, the apps, you can do it. One thing, we're partnering with the Open Roaming Organization. This document's out there on the web if you want to read it. What's interesting, it's about creating a specification for seamless and secure onboarding of IoT devices through Wi-Fi. You walk into a facility, you plug it in, it can connect securely, not just to an open roaming network, but to a Wi-Fi network of your choice. And it's using FIDO to achieve that. So effectively, it calls up, it says, who owns me? Hey, you're on this network over here. Thanks, I'll go to that network. All of that. So if you're interested, that's something we're working on. In terms of the portfolio of FIDO, let's just walk through it. You've got human authentication with passkeys. You've got onboarding, whether it's IoT, edge, or data center with FIDO. You've got the ability to deliver software with BMO, and then with the work we're doing with the WBA, you've got the capacity to be able to connect to a Wi-Fi network. As software professionals, you're worrying about an awful lot of stuff here when it comes to security. When you look at it, you can address a lot of that by using the FIDO technologies. It's literally ticking off a lot of those boxes, and these are open standards available to all of you. Now, hopefully, you're kind of interested. You said, well, it doesn't sound too boring, but I kind of want to know if it's real. I want to dig in a little deeper. And our colleagues here at Lenaro have been very kind. They've given us a session this afternoon. We're going to walk through, kind of remind you how it works, talk about the roles of people in the supply chain. Who does what in that supply chain between the manufacturer, the VAR, the distributor, the system integrator, the person that's running the platform. We're going to talk in detail and have an open discussion about where we are on BMO and where it's going and what you think it should be. How you can store the credentials, TPM or otherwise. We're going to do a run-through of the code. You've got multiple open source implementations on Linux Foundation, Edge. You can get Rust, you can get Go, you can get C, you can get Java. They're all available. We're going to have a conversation about the client software and how to drive that. We're going to talk about data center. We're going to be joined by two people. One is Brad Goodman, who is a senior architect at Dell Technologies, and he will be coming, and as you might imagine, they know one or two things about Edge and data center, and we'll be joined by Jeff Cooper, who is actually the co-inventor of the FIDO technology and the former senior architect at Intel. And then we'll be getting into the, what comes next. So with that, I just want to say thank you for your time. Hopefully you found something useful there, and thank you, Bill, for inviting me. Cheers.